more difficult aspect of complex number is taking a complex number to any power. So that's kind of almost the most difficult thing. There is another level of that difficulty, but let's consider that. So here we have, they are telling us to use the theorem. I don't speak French, so it's a Frenchman theorem for me, to write complex number taken to power. So if you think about it, okay, let's for a moment forget it's a complex number. If let's say it was 3 taken to the power of 9, we put that in the calculator and we get our number. Actually, let's see how much is 3 to the power of 9, just for the sake of curiosity. One big number, 19683. Now, what we have here, 3 is the base, 9 is our power, and therefore the outcome of that is the product. So when we have a complex number that is taken to power and we need to arrive at the outcome of that, so therefore we are looking for product, we go from rectangular form back, finishing with rectangular form, but to cross over we have to change it to polar form. Why? Because this theorem is only used in the polar form. That's the reason why we have to change that. So how do we do it? First, we change the number to the polar form. Once we do that, then we apply the theorem that is in our table, and then we simplify. Basically, we are going back from the polar back to rectangular. So that's the main idea. So how do we change a number from a rectangular form to a polar form? So those are the 3 elements that we have to do. Why? Because every complex number in polar form has r equal cos multiplied by theta plus I multiplied by sin of theta. So I need to know what is the value of r and what is the theta. Now, I'm always having that as an additional because I need to know where my complex number is. That's very important here. Okay, so let's apply this knowledge to the given question. So first, finding the value of r. So my a, the real value 1, so is 1 to the power of 2 plus b is what? Minus square root of 3. Always don't forget that minus will come with our number to the power of 2, everything under the square root. And this is really straightforward because all we do, we put that in the calculator, press equal, and we get that r is 2. Now, when it comes to finding that theta, that angle, so it is tan minus 1 value of b, which is minus square root of 3, divided by value of a, which is 1. Now, when we put that in the calculator, we're going to get what? Minus 60. Why is that minus 60? That's where the position of complex number come in. So let's mark where our complex number is. So the real value is what? Positive, but the imaginary is negative. So it is positive, and then imaginary negative. Therefore, somewhere here I have a complex number. The reason why we are getting minus 60 because is here. That's 60. That angle is here. That is 60 angle. However, we always measure angle from the positive side all the way here. So that means in order to get the actual theta, that will be the full circle, 360, minus our angle here, 60. So therefore, theta will be 300. So that's how we get that. So let's write our complex number in the polar form. So r being 2, cos theta is 300, plus I multiplied by sin, and theta again is 300. And let's not forget, that's what we are taking to the power of 9. Now, applying the theorem, how does it work? 2 is taken to the power of 9 in this case, and then our angle is multiplied by 9. So 300 multiplied by 9 plus I, and again, sin 300 multiplied by 9. So we apply the theorem. We change from rectangular to polar form. Now we apply the theorem. The next thing is to simplify. So basically go back to rectangular. How do we do? 2 to the power of 9 multiplied by cos of 300 by 9. And then again, 2 to the power of 9 multiplied by sin of the same angle. So when we put that in the calculator, the first part will be what? 512 plus, and let's not forget I, and then again 2 to the power of 9 multiplied by sin, we're actually going to get 0. So therefore, oh, my apologies, I forgot about the minus, it should be minus 512. So therefore, really the final answer is minus 512. That is the answer here.